लाइव है।
2 मिनट बाद चलेगा, 2 मिनट पीछे रहता है।
नमस्कार, वेलकम टू इंडियाज लार्जेस्ट लर्निंग प्लेटफॉर्म Unacademy. I am Pankaj Kumar, and this evening we are going to discuss problems in linear algebra. And yes, the topic is what? Do you know? The topic is positive definite, okay, semi-definite, negative definite, positive semi-definite. Okay, if a matrix is given, then how can you say this? All right. So certainly, first of all, we will discuss all the results. Okay, and thereafter, certainly we will have a lot of questions to boost up our confidence. Okay, so this evening I am happy because I am feeling comfortable now. This is my 5th live session on this Unacademy official YouTube channel. All right, so before starting this session, before going through a lot of questions, I would like to say that on Unacademy I am teaching in CSIR UGC net category since 3 years, and on Unacademy Special Class, okay, 126 plus free live sessions has taken by me. So you can access all these lectures on real analysis, linear algebra, and various topics free of cost. So certainly you can download Unacademy learning app, okay, and then in CSIR UGC net category you can follow my profile, and certainly you can go get all these 126 lectures for free. If you want to get more help, then certainly you can take Unacademy Plus subscription by using the referral code PK Maths. These days I am teaching complex analysis, revision and mastery course in complex analysis. My all the courses are in English medium, right? So certainly this course is about to complete, and I had already completed 23 courses on Unacademy platform. Okay, and with me there are more than 10 or 15 active educators. You can access all the recorded lectures, all the ongoing lectures, and all the upcoming lectures by all the educators after getting the subscription. Okay, so PK Maths is my referral code. All right, now I would like to say that this ordinary differential equation and partial differential equation is going to be started from 5th January. Okay, and this is also a revision and mastery course in ordinary differential equation and partial differential equation, right? Yes, this is also a revision course for our upcoming exam. And if you want to get the subscription, then please use the referral code PK Maths, and certainly you will get all possible discount. All right, I would also like to say that on Unacademy Plus, okay, for 24 months you have to pay 18,000, but if you will use the referral code PK Maths or PK Maths Live, then certainly you will get 10% discount, and for 2 years you have to pay 16,000 something. Okay, for 2 years. For 24 months you have to pay only 16,000 something. So if you are in BSc, then certainly you can take this subscription. You will get 4 chances to attempt your CSIR net under the guidance of educators on Unacademy. For 12 months it is 13,050 only, and if you will use the referral code PK Maths, then certainly you will get 10% discount, and you will be able to avail all the courses within you can say on less than 12,000. all right, and I would also like to say for 6 months, for 3 months you can see the things. And one more thing, here is what view all plans. So if you will click over here, then for certain limited period 1 month subscription is also available. Okay, but here you have to click, and for 1 month you have to pay only 2,900. But if you will use the referral code PK Maths, then certainly 10% discount, so you will get less than 2,900. You will get your subscription on less than 2,900. Okay, certainly we used to provide Unacademy iconic okay, in which one-to-one live mentorship, expert sessions and study booster sessions are going to happen. You have to pay a little bit more for that. Okay, so how can you get the subscription? You can go to my profile, okay, and thereafter you will get subscription option. Use this referral code and certainly you will get 10% discount. Okay, this is a limited period offer, okay, for 1 month. All right, and it is especially for our upcoming CSIR net exam, because if you will get this subscription, then within 2700 you will be able to access all the previous recorded lectures, all the ongoing lectures and all the upcoming lectures by all the educators in English and Hindi medium within. So you can get the full course on less than 2800. But certainly if you will use PK Maths, then certainly you will get 10% discount on this also. So certainly you can get all these things. All right, I would also like to say that in Unacademy Special Class, I had taken 126 plus free hours. Okay, so by downloading Unacademy Learning app, okay, and yes, to enter in the class, you can use the referral code PK Maths and you can watch all these lectures for free without any cost. And now I would also like to say one mega offer is there, that if you will take the subscription today, then certainly you will get 2 months extra. Okay, on the subscription of 12 months, you will get 2 months extra for sure. All right, and use the referral code PK Maths to get 10% discount. Or you can use this referral code to enter in the class. You can use PK Maths or PK Maths Live. Both will work equally. So now it's the time to start our revision. Okay, so a quick revision and thereafter a lot of problems will be there in front of you. So first of all, you can see a quick revision because before starting the game, before start to play, there are some warm-ups. Okay, so that you people will play well. A lot of questions will come in front of you and certainly it will be interesting to see that who will play how. Okay, so if A is any real matrix, then A transpose is always non-negative definite. Okay, if A is any real matrix, then A into A transpose will be what? Always non-negative definite. You have to remember this. Okay, in detail we have discussed all these things in our special class. If A is any non-singular real matrix, then A transpose is always positive definite. Okay, if it is non-singular, means if its determinant is also not 0, then it will be what? Always positive definite. There are a lot of characteristics of positive definite. Okay, another thing is what? If you have leading principal minor of a square matrix A, what are the leading principal minor? If you have n by n matrix, then this is a leading principal minor of order 1 by 1. This is the leading principal minor of order 2 by 2. This is the leading principal minor of order 3 by 3. This is the leading principal minor of order n by n. So leading principal minor of a square matrix is this, and this also characterize the nature of positive definiteness. All right, so if your all leading principal minors are positive and your matrix is also symmetric, then you will say it's positive definite. Okay, so after going through these results, are you people able to say that what will be the answer of this question? Okay, a non-negative definite. If you are given a non-negative definite matrix, then it is either positive definite or it will be positive semi-definite. This is also a result if all its leading principal minors are positive. Okay, and if you are given a quadratic, in our special class we have discussed that how can you write a quadratic into this form. Okay, XTAX, this A where what? Your symmetric matrix, you can see over here. So what would you like to say? Please do comments for this question. If you are given a matrix A 1 2 5 2 7 11 5 16 27, then what would you like to say for your A transpose? More than one answer will be correct. It's a question of 4.75 marks. What would you like to say? Please let me know. I want to see your names in the live chat. Come on, guys, do it now. You have to see whether it is singular or non-singular. All right. And you can see A is what? Any real square matrix, then its A transpose will be always non-negative definite. But how shall you say it will be positive definite also? If you will find its determinant, then you are going to get its determinant is what? Its determinant is what? 0. Okay, so as its determinant is 0, so it will not be positive definite, but certainly it will be what? Positive semi definite. All right, it will be positive semi definite. अगर डिटर्मिनांट भी नॉन जीरो हो जाता तब ये पॉजिटिव डेफिनिट भी हो जाता, राइट? सो बी एंड सी विल बी द राइट आंसर. Non-negative definite, why? Because A is any real square matrix, then A transpose will be always non-negative definite. But as its determinant is equals to 0, and if you will try to find its rank, then certainly you will write its echelon form. So you will make these two 0, then you are going to see that its standard form is this. Okay, so you can see its rank is what? 2. Its rank is 2. All right, so sir, and it is what? A singular matrix as well, so it will be what? Positive semi definite as well as non-negative definite. I am still waiting for your answers. Okay, I think you will give the right answer for this question. All right, if you are given a matrix A is equals to 1 2 5 2 7 11 5 16 28, then what would you like to say about A transpose A? Will it be positive definite? Will it be positive semi definite? Will it be non-negative definite? Will it be none of the above? What would you like to say? I am waiting for your answer. Results related to a positive definite, positive semi definite, non-negative definite, everything has already discussed in our special class, and some results has discussed in the beginning of this class also. So you people will be able to say the fact. Okay, more than one option may be correct. This time Sheba Thomas can be seen, and Sheba Thomas has given the right answer. Absolutely right, Sheba, because you can see this matrix A was there, and when we are going to find its determinant, then we are going to see it is non-zero. So it will become what? A is non-singular real square matrix. Okay, non-singular real square matrix. Therefore it will be what? Positive definite. And as any real square matrix A is given, then A transpose A will be what? Always non-negative definite. So that's why it will be positive definite as well as non-negative definite. Okay, so now let's go for the next question. Yes, this is the question. Which of the following is our positive definite? You are given 4 options right here, and certainly you can put the correct answer for sure. Try your level best. Okay, if you will go through all these results, then certainly it will help you to go through with the results and applications of positive definite, positive semi definite, non-negative definite, and all. More than one correct answer may be there. Okay, more than one. It's a question of 4.75 marks. Come on, guys, please put your answer. We'll discuss it at 7:18. I am giving you 2 minutes for this. Come on, please put your answer. Only 2 minutes to go. Come on, Sheba, if you are there, then please put your answer. Some people have arrived, and I think certainly I will get some correct answers in the live chat. First of all, if you will see, yes, Sheba is there, but Sheba, you are saying A, B, D. So, is this symmetric, Sheba? Is this symmetric? The answer is no. So, you can say what? All leading principal minor are positive. All leading principal minor are positive. Okay, but it's not symmetric. And that's why you will say what? It's not positive definite. Here in this case, you can see it's symmetric plus all leading minors are positive. So it will be your answer. Here the leading positive minor is negative, so it is not going to be. And here in this case, you can see what? If you will find it's leading, because this is the leading principal minor, right? So you can see what? It's positive plus symmetric. So it will become positive definite. Alright, so B and D are its right answer. Is this clear, Seba? Are you agree with this, or do you want to say something more? Is this clear? Should we go for the next? Yes? Clear. Now let's go for the next question. I will ask a lot of true false, as I always ask on our Unacademy app. Okay, so yes, I am going to ask a lot of questions. If A and B are positive definite matrices, if you are given A and B and these are what? Positive definite matrices of same order. These are positive definite matrices of same order. Okay, then you have to say, if A and B both are positive definite matrices of same order, then my question is A minus I positive definite? Is A minus I positive definite? Yes or no? This is the first part of the question. Shiba, what would you like to say? Is A minus I positive definite? If A and B are positive definite matrices of same order, then what would you like to say? Is A minus I positive definite? Shiba is saying no. Okay, because if your eigenvalue of A, if eigenvalue of A is half, which is possible, then eigenvalue of A minus I will become what? Half minus 1, which is minus 1. So it's not possible. So it is not possible at all. Okay, A and B are positive definite, then I am going to ask you is, if A and B are positive definite, then is AB positive definite? Okay, then what would you like to say? Is your AB positive definite? Yes or no? Please put your answer. If A and B are positive definite, then their product will be positive definite. Yes or no? Yes or no? Will it be always positive definite? Yes or no? Come on. अगर A और B पॉजिटिव डेफिनेट होगा तो दोनों का प्रोडक्ट भी पॉजिटिव डेफिनेट होगा. दिस इज द क्वेश्चन, बट द आंसर इज नो. Okay, its answer is no. Why? What is the reason? The reason behind that is okay, A and B are any square matrix, then AB will be symmetric. If and only if your AB is equals to BA. But generally your AB and BA are not always equals to each other in matrix multiplication. That's why if your A and B are positive definite, then it is not necessary that their product will be positive definite. Right? Okay, now let's go for the another one. If your A is positive definite, then is A square plus I. A square plus I positive definite? If A is positive definite, then A square plus I positive definite? Yes or no? Okay, please put your answer. If your A is positive definite, then is A square plus I positive definite? Yes or no? Please put your answer. If A is positive definite, then A square plus I positive definite? Yes or no? Its answer is yes. If your A is positive definite, then A square plus I will be positive definite also. And what is the reason behind this? Because if your A is positive definite, then certainly your A is symmetric. Sheba is saying no, but I am giving the answer over here. If A is positive definite, then A will be what? Symmetric matrix. I is already symmetric. Okay, and if your A is symmetric, then A square will be also a symmetric matrix. Okay, and if your A square is symmetric, I is symmetric, so A square plus I will be symmetric as well. Okay, so you can see what eigenvalue of A square plus eigenvalue of I, okay, will be always positive, isn't it? So you can see the eigenvalues of A square plus I is positive, isn't it? And A is symmetric as well. So you will say what? Yes, this is going to be all right. Okay, now I am going to ask one more question. If A and B, these two are positive definite, if these two are positive definite matrix, then A plus B is also positive definite? Yes or no? A plus B is also positive definite? Come on Sheba, please put your answer. If A and B are positive definite, then A plus B will be also positive definite? Yes or no? Think and say. If A and B are positive definite, then A plus B will be also positive definite. Yes or no? Seba, please put your answer if you are there. Yes, this time absolutely right. Seba is saying the right thing. In between, Vishalji has arrived. So Vishalji, you are saying the right thing also. Okay. So as your A is positive definite, so all the eigenvalue will be positive. Okay, B is positive definite, so all the eigenvalue will be positive. So A plus B will have eigenvalue positive. Okay, and being positive definite, it will be symmetric. It will be symmetric, and so we can say A plus B dash is equals to A dash plus B dash, which is equals to A plus B. So you can say what? This is symmetric as well. Therefore you shall say yes, it's positive definite. Now I would like to ask one more question, that if A is positive definite, then e to the power A minus I, will it be positive definite? Yes or no? If your A is positive definite, then e to the power A minus I will be positive definite. Yes or no? Put your answer. Come on. Will it be positive definite? Come on, guys. Yes or no? This time shape. Okay, I think nobody has comment anything. If A matrix is positive definite, सर लाइफ साइंस की क्लासेस कहाँ होती है? शुरभी मैम के लेक्चर्स, आई थिंक आई डोंट नो बिकॉज वी आर फ्रॉम मैथमेटिकल साइंस, बट विदिशा, I would like to say that if Surbhi ma'am is on Unacademy, then certainly you can go in CSIR net category and you can just write her name, then certainly you will get that. Okay, and she might come on this channel also, I don't know actually, for life science. Okay, so come to this question. If A is positive definite, then e to the power A minus I will be positive definite. Yes or no? Come on, Vishalji, Sheba, if you people are there, then please put your answer for this question. The answer will be what? Yes. Do you know why? Because if A is positive definite, all right, so yes, Sheba, so its eigenvalue will be greater than 0. Okay, and its eigenvalue will be 1. So e to the power anything greater than 0 will give you the value greater than 1. So finally it will be greater than 0, right? And as A is symmetric, so that condition will be also satisfied. So you will say yes, this is going to become positive definite, no doubt. Okay, now I am going to ask another question. All right, another question. If your A is positive definite, then what would you like to say about 50,000? 50,000 A minus I, will it be positive definite? Yes or no? Come on, Sheba. If A is positive definite, then what would you like to say about 50,000 A minus I? Will it be positive definite? Come on. Yes or no? Thereafter, I will ask a CSIR net question. After this, we'll ask a CSIR net type questions. Pooja Koshik is saying, what is the difference between infinite and infinitely many? Okay, Pooja, I would like to say that if you are asking this question, then certainly your context may be countability. Okay, because there are some infinite set which may be countable, right? And there are some infinite sets which may be uncountable also. So you are asking what is the difference between infinite. So okay, infinite or infinity if you are writing, so infinitely many elements are there, it means your set may be countable or uncountable. But if you are saying infinite means just a symbol infinity, then that is just a sign or convention that represents the largest real number exist in nature. So when you are saying infinitely many, then it may be a countable set, it may be an uncountable set, it depends on their cardinality. Okay, because you had written difference between infinite and infinitely many, so I have understood only this context. But it will be better if you will say on which context you are asking, then certainly I will reply better. So Seba is saying no, and the answer is right, because it is what? 50,000 A. Okay, so if your A is positive definite, then there is a possibility. If I am saying there is infinitely many number between two rationals, certainly it's right. There are infinitely many irrationals between two rationals, and vice versa, and actually rationals and irrationals are dense in R. Okay, so 50,000 into A is there, so certainly there is a possibility that its eigenvalue may be 1 by 1 lakh, and in that case 50,000 into 1 by 1 lakh will be 1 by 2 minus 1. So there is a possibility that its eigenvalue may be negative. Okay, and if there is a possibility that its eigenvalue will be negative, then we cannot say it will be positive definite. All right, now let's go for a CSIR net question. Okay, by using Archimedean property, you can certainly prove that there is infinitely many number between two rationals, and that will be uncountable in number actually. Okay, between two rationals there will be uncountable number of numbers, and their cardinality will be strictly greater than aleph naught. All right, but if you will take another infinite set like Z, or any set equivalent to Z or naturals or rationals, then it has infinitely many elements, but they are countable in nature, you know already. Okay, so certainly we will take sessions on countability and uncountability, but this evening is dedicated for this question. If S is equals to A n by n such that determinant of A is not equals to 0, all right, and Aij belongs to R, set of reals, and Aij is equals to Aji, all right, for all I comma j. Okay, see the question carefully and then you should try your level best to answer. Option A is what? E to the power Pa minus I is positive definite, for all A belongs to S. Okay, option B is what? A to the power P is positive definite for all A belongs to S. This is your set S. Okay, option C is what? A to the power minus P is positive definite for all a belongs to S, and option D is what? A plus pi is positive definite for all a belongs to S. Okay, so there are this much of options. I would like to say that on Unacademy you can talk with your educators also. On Plus, there is a facility you can raise your hands, and certainly you can talk with your educator, because in online classes, if you are asking anything, then what is the context behind the question? Sometimes by reading words we are not able to understand, right? And in that way, if we will talk, then certainly we will be able to understand each other better. And that's why Unacademy has introduced then that if you will have any doubt in between the class, then certainly you can raise your hand, the educator will allow you to talk, and there will be a one-to-one interaction with your educator for sure. Okay, so yes, so now this is the question over here. If S is equals to A n by n, determinant of A is not equals to 0, and Aij are real, Aij is equals to Aj for all I comma j, then what would you like to say? Which will be true? More than one options may be correct. Please put your answer. I am giving you 3 minutes for this. Come on guys, put your answers. Only 2 minutes remaining, and who will give the answer? It will be interesting to see. I cannot do the poll on YouTube right now. For that I have to buy a smart board. Come on guys, put your answers. You have to see the conditions that A is what? A square matrix. Aji is equals to Aij. Okay, condition of symmetricity is also there. Okay, determinant is non-zero. So if you are going to take a positive definite matrix, isn't it? Sorry, determinant of A is not 0. So it may be, your determinant of A may be negative as well. It all depends. Okay, so I would like to say this option is not going to be true. Do you know why? Because e to the power pa minus I is there. So its eigenvalue will be 1. And here think, if its eigenvalue of A, if it will be negative, then what will happen? E to the power negative will be less than 1. And in that case, anything less than 1 minus 1 will give you negative eigenvalue. And in that case, it is not going to be positive definite for all A belongs to S. Because here is the word for all. So for all A, it is not possible. Now you can see A to the power P is positive definite for all A belongs to S. So what would you like to say? What would you like to say? Okay, so if you will take this P as even natural number, then what are the thing you are going to see? Eigenvalue of A to the power even, then certainly it will be what? Positive. So there exists a P even natural number, so that A to the power P and A to the power minus P also will become what? Positive definite. So that's why B and C will be what? Positive definite also. Because there always exists a even natural number, so that A to the power P will be there, and certainly you will get what? A positive eigenvalue for sure. All right. Yes. Okay. But here there is a problem. This is not going to be. What is the reason behind this? For example, if you will take one of its eigenvalue as minus 2000 and your p is equals to 1000 and 1000 into 1, then if you are going to add these two, then you are going to see what? Minus 1000, which is less than 0. So there is a possibility that its eigenvalue will be what? Less than 0. So for all a belongs to S, this is not going to be. So its right answer will be what? B and C only. Is this clear? Now I am going to ask some more beautiful question. All right. Question is 3 marks, CSIR net type. Okay, for what values of ABC? For what values of ABC? For what values of ABC, where ABC are real, the matrix A is equals to A, let me write it clearly. The matrix A is equals to A, 0, C, 0, 1, B and CB1. It's a 3 by 3. For what values of ABC belongs to R, the matrix, this is positive definite. Okay, option A is what? A greater than 0 and A is greater than AB square plus CA square. Option B is what? A greater than 0 and A is greater than A plus CA square. Option C is what? A greater than 0 and A is greater than A plus B square. And option D is what? None. So you have 4 options over here and you have to say the right thing only. Come on guys. For what values of ABC belongs to R, this matrix is going to become positive definite. Come on, please put your answer. No, P is, because if you will take P even integer, okay, you are able to find an even integer, so that this is going to become positive definite for any A belongs to S. That's why you will say A to the power P will be positive definite. All right. There always exists an even natural number P such that A to the power P or A to the power minus P will be what? Positive definite. For P is equals to even natural number, we are saying. Okay, you are free to choose your P. Right, Shiba? You are free to choose your P. That's why you are able to say that. Alright, so please let me know what would you like to say. In between I can see Zafar Hossain Sahab is there with the answer and he is saying, I will make some suspense because I want some more answers in the option. Shiba is also saying the same thing, but I want to see some more answers and then we'll declare which is right, which is wrong. Come on guys, please put your answer. So I would like to say Zafar Sahab was saying the right thing and thereafter Sheba has also arrived with the right answer. Because this matrix is what? Symmetric. We can easily see that this matrix is symmetric, and for a positive definite, what we need actually, if all its leading principle are positive, if all its leading principle will be positive, only then we can say that, okay, because one condition is already okay, being symmetric. So now you can see what, it's one by one leading principle minor is what, a. So you can see one by one leading principle minor determinant of a should be greater than 0, and this is possible only when your a is greater than 0. Alright, so this is one by one leading principle minor. Thereafter another leading principle minor of order 2 by 2 will be what, a0, 0, 1. So from 2 by 2 we are also going to see this is 2 by 2 leading principle minor, and this is also what, a, it should be greater than 0. So from here it is clear that your a should be greater than 0. Okay, so 1 by 1 order principle minor, 2 by 2 order principle minor greater than 0 implies what, your a will be greater than 0. But what about 3 by 3 principle minor? So for 3 by 3 principle minor, it will become a0 c, a1 b, c b1. And you can see its determinant should be also greater than 0. When you will expand it along this row, then finally after expanding this determinant, you are able to say a into 1 minus ba square minus ca square should be greater than 0. And from here you will not hesitate to say that your a will be greater than aba square plus ca square. So this will be the required condition, okay, because all the, it should be symmetric, which is already, and all its leading principle minor should be greater than 0. So 1 by 1 leading principle minor or 2 by 2 leading principle minor implies this condition that a will be greater than 0. And when we are making 3 by 3 leading principle minor should be greater than 0, then we are going to get this beautiful relation. So I would like to tell you all that a special class, okay, in a special class a course in linear algebra is going on. Course in linear algebra is going on. My name is Pankaj Kumar. You can follow me in CSIR UGC net category, okay. And in a special class I had already taken 126 plus free lessons, okay. In linear algebra you will be able to access continuous 60 lectures, okay, concept wise. The questions you are seeing over here, okay, all these things has been discussed concept wise on our special class on Unacademy. So you can download Unacademy learning app, you can select CSIR UGC net category, you can follow Pankaj Kumar, okay, you can enter in the class by using the referral code either PK Maths or PK Maths Live. My all the lectures will be in English medium, ओके एक्चुअली मुझे हिंदी भी आती है, लेकिन मुझे जो रिस्पॉन्सिबिलिटी दी गई है वो इंग्लिश मीडियम के लिए दी गई है. ऑल राइट, सो ऑल द लेक्चर्स आर इन इंग्लिश मीडियम, बट माई इंग्लिश इज एज गुड एज योर्स. So certainly we will be able to understand each other without any hesitation. You can access and enjoy all these free lessons for sure. I would also like to say that we'll continue linear algebra special class on our free special class session. That will be the 22nd lecture, 21st lecture, in which we will discuss what quadratic form in linear algebra. Okay, we will discuss the concept of signature in quadratic form. Okay, and we'll discuss a lot of properties related to this quadratic form and positive definiteness, because positive definiteness is going to be defined in terms of quadratic form, in terms of matrix, in terms of properties of matrix. The relation of signature is also there with the quadratic form and matrix. Okay, so in the 21st lecture of linear algebra, which is already going on, so you can watch all these 20 parts. Okay, and everything will be in a proper sequence. The timing of the class is 8. Yes, the timing of my every class on Unacademy Special is 8 p.m. Okay, so please check my profile. You will get many things without paying anything. All right, in a special class and in free lectures, you will be able to access many interesting things for sure. Okay, and for the upcoming exam, the best thing will be what? You can buy the plus course on only 2900 for 1 month, and you will be able to access all the previous recorded lectures, all the upcoming and ongoing lectures by all the educators in English medium and Hindi medium. And if you will apply this referral code PK Maths Live or PK Maths either to enter in the class or to take the course, then certainly you will get 10% discount and it will be less than 2800. Okay, so for 1 month you can buy the complete course on less than 2800. Okay, so if you want to buy the plus, then you are welcome. Otherwise, you can watch our free live sessions on Unacademy for sure at 8 p.m. At least 11 sessions will be taken per month in a sequence. All right, so certainly we will meet on this Unacademy official YouTube channel again. With this promise, I would like to say thank you very much everyone for watching. If you people want to ask anything, then certainly you are welcome to ask, and we'll meet in the next class. Till then, I would not like to forget to say thank you very much everyone for watching this. Thank you very much. One more thing is what? If you will take 12 months subscription, then you will get 2 months extra. Okay, and if you will use the referral code PK Maths, then certainly you will get 10% discount for sure. All right, thank you very much Sheba, and I think you will come on our special class and will continue this lecture for sure. Okay, you can see after going to my profile, you will see this live classes. This is for plus, but in a special class there are 126 plus free sessions. There is no special class today, Jafarji, but I will conduct my next special class on 1st January. Okay, if you will follow my profile, then you will get notification in community. Okay, if you will follow my profile, then certainly you will get all the links. All right, and there is a Telegram channel also. So on our Telegram channel you can join everything. Let me share the Telegram channel link. Just wait. Yes, this is our Telegram channel. All right, you can see this https://t.m.e. So if you will join this Telegram channel by clicking on this, you can join our channel. Are you not able to join? Yes. All right, let me put it into the comment section. All right, so in the live chat I had written, I have sent the link. You can click on that and you can join our channel for continuous touch. Okay, so certainly we will continuously meet on our YouTube channel. Okay, on this Unacademy learning platform, and in a special class we will also meet in plus class, iconic class, anything according to your convenience you can choose. Any more questions will be welcome. Otherwise, I will say good night. Okay. So thank you very much everyone for joining. Okay, we'll meet in the next class. Till then, take care. Bye bye. Thank you. Anything? Okay, Jafar ji.